here at Questacon in Canberra, and this good sized sphere is made of Australian granite. It's actually 75 centimeters diameter, this sphere, and it has a mass of 633 kilograms. It's pretty cool by itself, but what's actually even cooler is that, you can probably hear in the video, in the audio, it's supported by water pushing up. So I can actually make the sphere move. I don't do that just yet. I moved it when I first arrived, and it took quite a while to get it to be pretty much stationary. So 633 kilograms of granite, this sphere. But of course it's being pulled down towards the center of the Earth by the force of gravity. Gravity on Earth is about 10 newtons of force per kilogram. It's closer to 9.81, but to make calculations easier, we can just say 10 for now. So 10 newtons of force per kilogram. So we have about 6,330 newtons of force pulling this granite sphere down towards the center of the Earth. You'll notice, however, it's not actually moving towards the center of the Earth. And that's because of that water that I mentioned earlier supporting it. It's applying a supporting force, or a normal force, stopping the object falling towards the center of the Earth. So the force of gravity pulling it down, its weight force, its weight of 6,330 newtons, is being supported by the normal force of the water pushing back upwards. Now the thing about forces, most people would say that a force causes movement. Well, let's see about that. It's not really the best thing to say. You can see actually it is slightly moving now. That's because there's another force acting on it. That's the force of the wind. It's a bit of a windy afternoon at the moment. By applying a force to the sphere, I'll push it across to the side. I can quite easily get it to move. I can do that because it doesn't have the friction between this granite sphere and the block that it's essentially resting on, because it's supported by the water. So there's very little friction there. So I can get it to move fairly easily. I can get it to stop fairly easily. But as I mentioned, people often think that forces make something move. Well, right now, the sphere is moving. Where are the forces? We mentioned the force of gravity, pulling it down towards the center of the Earth, fine. And the normal force, the supporting force from the water, counteracting that force. So, in a sense, cancelling it out, those two forces are balanced. But the sphere is moving, there are no forces acting on it. So forces and motion, forces and movement, they're not the same thing. Forces are involved in motion, but they're absolutely not the same thing. We can have, as we see here, motion, but no force. I can actually push on the block here. I'm pushing harder, and yet it didn't move. There was no motion. There was force there, but there was no motion. And with the sphere we have motion, but there's no driving force. There was initially. I did push on it initially. I supplied a driving force, but we now have motion and there is no driving force. So forces and motion, not the same thing. So what do forces actually do? Forces accelerate an object. Here I'm applying another force. I'm pulling it back towards me to slow it down. And in slowing it down, I accelerated the sphere. I changed its motion. Remember, acceleration is just about changing motion, maybe speeding up, maybe slowing down, maybe changing direction. So when I supply a force, what I'm actually doing, we shouldn't really say that I'm moving the sphere, we should say that I'm accelerating the sphere. Here I'm accelerating it in a counterclockwise direction. I could accelerate it back the other way. First it will slow down, it will temporarily stop, and then it will start to move the other way. So first I accelerated this way, and then I accelerated it the other way. And we had the change of motion. The sphere accelerated. I could accelerate it in this direction by pushing it up and over. Supplying a driving force, this push, I accelerated it this way. But now that driving force is no longer applied. I've still got the motion. The ball is still moving. It's not changing its motion because there's no longer that driving force. Remember, we still have gravity and we have the normal force. They cancel out. Those forces are balanced. There's no driving force now pushing it along. So there's no change in motion. That's what forces actually do. They change the motion of an object. Maybe make it speed up, maybe slow it down, maybe change the direction of motion. So instead of saying that forces make something move, we should really say that forces change the motion of an object, or forces accelerate an object. If I push a little bit, if I supply a small driving force, then the sphere starts moving a little bit, it accelerates a little bit. If I apply more driving force, there's a greater change of motion. It sped up a lot more. So we say that it accelerated a greater amount by supplying a greater force.